All right, so for these multiple choice problems, I was looking for, let's see here. Let R of t be the rate at which water drains from a tank and t be the number of minutes elapsed. Which of the following best describes that thing? Okay, so R of t is the rate at which yeah, so if I want to do this accumulation over the first four, from minute 1 to minute 4, so that would be the number of gallons of water. Let's see here. The change in the rate, change in the number of gallons from 1 minute to 4 minutes. Yeah. So when I take that integral, I'm looking for a change in the number of gallons here. So the change in the number of gallons. So an integral is an integral of a rate is the net change. That's kind of the idea. Let f be a positive strictly increasing. Which of the following approximations is the largest? So it's positive and strictly increasing. So if it's strictly increasing like that, I know that R4 should be, so we're going from 2 to 4. So I know that R4 will be a right-hand sum, will be an overestimate, right? The left-hand sum would be an underestimate. And the midpoint would probably be, if it's strictly increasing, yeah, the midpoint's going to be, would be smaller than the right-hand sum. So if it's strictly increasing, then the right-hand sum would be the greatest. Okay, suppose f is an even function, and we have that. Find integral from 2 to 5. Okay, so if we have an even function, so an even function is, has this symmetry about the x-axis, something like that. So the integral from -2 to 2 is 6. And the integral from 0 to 5 is, -5 to 5 is 14. So since it's even, that means that the integral from 0 to 2 would be half of 6. And the integral from 0 to 5 would be half of 14. Okay, and so then I want the integral from 5 to 2. So the integral from 5 to 2, or from 2 to 5, excuse me, f of x dx, will be the integral from 0 to 5, f of x dx, minus integral from 0 to 2, f of x dx. And this I know to be 7 minus 3, which is 4, is the correct answer. Okay. So let me switch over to the next page. Okay. So on this one, I'm given an expression that's the Riemann sum approximation of which of the following. So the 3/10, let's see here. So I'm dividing it up into 10 pieces here, and it's an interval of length 3. So these are the only ones that are intervals of length 3. Because they go from 1 to 4, 1 to 4. Yeah. So if I plug in 1 first, if I plug in 1 for k, I get 1 plus 3/10. So it's going to be a right-hand sum. So this is 1, and this is 1 plus 3/10, and then so on. And if I plug in 10 there, I get 1 plus 3, which is 4. So my starting point is at 1, and my ending point is at 4. So it's one of those two. And my distance here is 3/10. So that's my distance of each of these intervals. And then the height is going to be given by plugging into a function. So this is what I'm plugging into a function. So the function is x cubed. So the answer is this one. So it's so when I take the areas of all these rectangles, it's going to be the width, which is the 3/10. Each of these have width 3/10, times the height, which is what I get when I plug this x value into the function x cubed. And then my starting point is 1, and my ending point is at 4. Okay, so this graph of the function is below. Compare the values of f prime of pi over 6. Okay, so f prime of pi over 6 is going to be the derivative there. I know that to be positive. So I can write f prime of pi over 6 is positive. Okay, what's the next one? F double prime of pi over 2. So f double prime deals with the concavity. That's concave down there. So I know f double prime of pi over 2 is negative. Okay, what about f of pi over 2 minus f of pi over 6 over pi over 2 minus pi over 6? That's going to be the slope of this line here, right? And I know that to be also positive, but smaller than that one. So, so I can say that this thing is also positive, but it's smaller than f prime of pi over 6. So f of pi over 2 minus f of pi over 6 over pi over 2 minus pi over 6 is positive, but smaller than f prime of pi over 6. Okay, and then what about the integral from 0 to 2 pi of this function? I can see that that would be the interval from here, the integral from here to here. I'll have this area plus that area, and that's going to be equal to 0. Okay, so let's order them then. I want to do the negative one first. So the negative one is f double prime of pi over 2. And then the smaller of the two positive ones. So f of pi over 2 minus f of pi over 6 over pi over 2 minus pi over 6. And then the next one will be the next positive one, which is f prime of pi over 6. And then the next one will be oh wait, I want to do the 0 one. Excuse me. So let me erase this. So okay, so the one that's equal to 0 is that integral. And then the negative one is f double prime f double prime of pi over 2. Okay, so that one's negative, that one's 0, negative 0, positive, but not as big as that one. Okay, so that's the ordering. So let's see which one works. I think it's this one, D.